Luminous intensity, also known as candle power, is the amount of light that a source emits. It is measured in candelas, CD. Luminous intensity tells us how different a light source appears. Think of it as how strong the light from a candle is. Luminous intensity I is equal to amount of light lumens over solid angle steradians. This formula shows that luminous intensity is the amount of light in lumens divided by the solid angle in steradians. Lumens measures the total light output, whilst the radian measures the spread of that light. Candela is 1 over 60th of the luminous intensity per centimeters squared of a black body radiator at the temperature of the solidifying platinum 205 2045 degrees Kelvin. This means that one candela is a standardized unit of brightness based on a specific scientific reference. A source of one candela emits 1 lumen per steradian. If you have a light source with one candela, it spreads its light evenly over one steradian, resulting in 1 lumen per steradian. Total flux 4 pi lumens. Total flux emitted 4 pi lumens. Since a sphere has 4 pi steradians, a light source of one candela emits 4 pi lumens in all directions. Luminous flux. Luminous flux is the total amount of light from a source passing through a given area. It measures the total light emitted by a source and is commonly used to measure total lamp output. It is measured in lumens and denoted by F(R). Luminous flux tells us how much light is coming out of a source, useful for understanding the brightness of bulbs or lamps. A lumen is the flux contained per unit solid angle of one candela or standard candle. 1 lumen represents the amount of light emitted through one steradian by a source with a luminous intensity of 1 candela. The power relation, where approximately 1 lumen is equal to 0.0016 watts. Lumens can be converted to electrical power, giving us an idea of how much energy is used to produce a certain amount of light. Lumen hour is the quantity of light delivered in 1 hour by a flux of 1 lumen, similar to watt hour. This unit measures how much light is provided over time, useful for comparing energy usage of different light sources. When light is thrown upon an object, the effectiveness of the illumination depends on the number of lumens the object receives and the number of lumens per unit of its surface area, measured in lumens per meter squared or lux. Illumination measures how well an area is lit. It depends on how much light hits the area and how spread out that light is. Factors affecting illumination are density of luminous flux, which is the amount of light falling on an object or plane. More light per unit area means better illumination. Distance, the intensity of light falls off the inverse. Intensity of light falls off as the inverse square of the distance traveled. The farther the light source, the dimmer the light will appear. because it spreads out more. Angle decreased by the angle at which it falls on the surface. Light hitting a surface directly illuminates it better than light hitting at an angle. Reduction factor. Reduction factor of a surface is given as the ratio F is equal to MSCP over MHCP, where MHCP is the mean horizontal candle power. It is also referred to as the spherical reduction factor. This factor helps compare light intensities in different directions, ensuring a uniform light design.